morning to all. Today we are going to simulate the gate netlist which is generated from the RC compiler Design Vision. The Cadence Virtuoso for the importing the gate level netlist from the RC compiler and the Design Vision. So basically it will be transformed into the schematic and the symbol in the Virtuoso, and the schematic is built from the transistor itself, which is referred to the some specific library. So we start with some presentation to get the details of the process, and then we go through the practical on the Virtuoso. Okay, it will be some symbol and the schematic for that, and there will be some simulation setup at the end, and we get the similar result that we seen on the earlier videos for the final state machines. So it might be happen that it is the rarest video you found this regarding this, and might be surprising how it will be happening. Okay, so we start with our presentation. This will be the part 1 based on the Cadence Virtuoso, and part 2 and part 3 also we consider for the digital platform simulation based on the VCS and the verilog or NC launch. So there will be the part 2, 3 like that. So today we discuss the Cadence Virtuoso, and the main part of this video will be how we can import the verilog, schematic and the symbol we create, and how we can set up the spectral analysis for the simulation setup. So we already know that RTL2 netlist generation has two parts, like one way from the Design Vision and second way from the RC compiler. So the main part of this process is nothing but our main source code, that is our verilog or VHDL files, some constraints for the port pins or reference files. So we are taking the 45 nanometer library. Whatever the library you have, you can refer that. So ultimately the resultant or the outcome of this process is nothing but the gate netlist and the other reports like power, area, timing. So these are the overview of the how we transform the RTL into the gate netlist. You can check my earlier videos for the Design Vision RC compiler under the EDA tool tutorial series. So we take the one source file FSM test1. It generated from the active SDL using the drag and drop method, and corresponding waveform you can saw on this presentation. It is just replication of the traffic light signaling or add some slide on this. This is simple final state machine. You can pause and check. Okay, and this is for this. Our main purpose to import the gate netlist into Cadence Virtuoso. So just for the reference I add this for you. Okay, this is a SDC file that I am using, and this is the library for the gate netlist generation with .vhdlv for the functions, verilog functions, and the leaf and data.db for the layout. Also for the encounter.map is for also layout. Cells.sp for the spice simulations. Okay, this similar files that generally any libs has, like for functional verilog VHDL files, then layout related db lib files will be there. Also for spice simulation there will be some .sp files will be there. Okay, and when I transform this RTL into the gate netlist through RC compiler and the Design Vision, these are the transformed gate netlist from the Design Vision. It will take almost 39 cells. Cells means whatever this buffer, D flip flop, and gates, inverters. These are the nothing but the cells. Okay, so earlier our RTL look like this. Okay, and after the transformation it will look like using gates. RC compiler takes less cells as compared to the design vision for the same code. Generally, I saw RC compiler took less cells as compared to the design vision. Cadence Virtuoso. So we need a reference library to have these cells. So we are referring the 45 free PDK cells. Any PDK has digital PDK has similar names, and gate 2x1 like that, and the inverters, full adders, flip flops, buffers like that. Also, I refer the 20 nanometer from the TSMC library, and it also has the same names that we found in any PDK or any technology library for the digital domain. We can use these libraries, or we can create our own library set using your own circuit but with the same names and same port. There is no special library required. You can create your own, but the name and the port arrangement should be same. One basic library we need for the supply pins, ground and VCC or VDD. So the process is simple. Go to the Cadence console file. There will be one import option, and under that there are different options for the import: verilog, VHDL, PI. So we are importing through Gate Netlist, so we can choose the verilog. Once you click on the verilog, the pop-up menu will come. It will ask for the target library name where this schematic and the symbol will go, and this reference is nothing but the technology files for the gate names and the evocation of the particular modules or cells for the conversion. One main library through which we can map our Gate Netlist cells, and the second is a standard basic library from which we take the supply pins. Okay, under this we just zoom it. We need a schematic, functional, netlist and symbol. Generally we need schematic and the symbol. Other things we not required. Okay, and these are the tab global net options. In global net option, we just to mention the power supply net, VDD exclamatory mark, ground exclamatory mark. These are the net expression, VDD and the ground. Schematic generation options are there. These are the standard values. These are the options values. So once you click the OK, it will generate that schematic and symbol and pop up a menu like process is executed. Okay, these are the logs related to that. At the last, we get the schematic for that FSM test one and the corresponding symbol. We will check in practical way. Using that symbol, I create one setup for the simulation. I provide the clock and the reset and supply pins of 1 volt, and we get the same output that we saw on the on the VCS and the Lord. Please subscribe my channel. Please subscribe and support me, and make comment for any improvement, and please hit like button. Refer this technology file TSMC 20 nanometer. These are the cells. If you have this, it's okay. Otherwise you can build your own with the same name and same structure. You can find any PDF for the schematic of this kind of cells. You can build your own. Okay, no issue. Only we need the schematic and symbol for the particular cells. Okay, so we have to. Okay, we refer this GNTS1 as a target library. In this, there is no cells for the FSM test one. We import using the file import, then verilog, then target library is GNTS1. These are the reference libraries. This is our Gate Netlist. All other settings are default in the presentations. Just click OK. Okay, window. Just log file, close. Just refer this by doing selection of other library. You find that there is a FSM test one. This is schematic using the cells that we are, and this is symbol for this clock and reset. X. This is a transistor level implementation of the OR cell. We need a setup for the simulation as similar to the any analog circuit simulation in this. So we create one simulation file. Okay, and I have one similar schematic. I just copy paste here, select, see, click here, and click here. Okay. Just remove this. Place our cell. Cell is region PS1. Browse. Okay. Hide. Close. Check and there is just 6 warnings. It's okay. This is floating kind of warning, so remove the warnings. Rule setup. Ignore. Save and check. Floating wires warnings. Need to launch ADEL. We need a spectra. Okay. Then we need model files. As we are using the TSMC, so for the TSMC P channel, N channel models we required. P channel, N channel. Okay. We don't need this one. Hit OK. Model are set. Analysis is transient 100 nano. 100 nano. Then we need to outputs like to be save and plot from the schematic. Clock. Reset. G R Y. Okay. Also save it. So just save this state. Okay. Just simulate. Split it. Select which is some width. Width is medium. So in this way we can have the transformation from the gate netlist to the level schematic in Cadence Virtuoso. Please make any comment to furthermore if you require any further details about this. Also, one important thing is that we need a spice file from this. Okay, you can go to the net simulation option, netlist, create or display. So this is a spice file for this circuitry. You saw their file for this simulation setup. These are some circuits using the transistors, and at last you find our main circuit, that is FSM. Okay, this file can be used for the simulation under the HSpice or SPICE or any similar spice for the spice simulations. So we will see in our tutorials, ADA tools, how spice file can we run. So similar, we get similar waveform on that also. So, but keep in mind that this spice file is coming from this analog design environment simulation netlist. Create. From this we are exporting actually the transistorized circuitry into the spice file. Okay. I hope this video find useful to you, and please subscribe my channel and support me. Thank you.